Hey guys, Gene Wells here. Day 2 of Unit 11. We have a cylinder, like a canister full of tennis balls, and there's 3 tennis balls in there. And the question says, a cylindrical can holds 3 tennis balls snugly, one directly above another. If the radius of a tennis ball is 6 centimeters, what is the volume of the can? What volume of the can is occupied by the air outside the tennis balls? So we're looking for all of the air left inside the canister that's outside the tennis balls. All the little spaces that are left inside. How much space is left inside after we figure out how much is taken up.
So guys, in blue, I'm kind of showing, what the space is. It's the air that's around the tennis ball and in between where the edge of the canister is. We need to figure that out, and the way to do it is to first figure out the volume of the actual cylinder itself. All right. So the first thing I'm going to do is first I'm going to move the video so we have a little bit more room to work with. There we go. And what I'll do first is, and I'm going to label it, this is going to be the cylinder. And if you remember, the formula for the volume of the cylinder is volume equals pi r squared times the height. Now, it gave us the information saying that the radius of one of the tennis balls is 6 centimeters. And since the tennis ball is fit snugly into that canister, we know that the radius of the cylinder is 6 centimeters as well. So I'm going to plug that in right now. So I'm just going to bring everything down, volume, leave in terms of pi. My radius is 6, and we know we're going to square that. But it doesn't give us the height. So this is what we have to figure out. Notice that there are 3 tennis balls in the canister. It's 3 tennis balls high. Alright, so what I'm going to do is I'm going to take that 6 centimeters, which is for the radius, so then the whole thing really is 12. And if it's 12 3 times, the height, the whole entire height of this cylinder is 36. Okay? That part you have to kind of problem solve, you have to kind of think about. Alright, and then the rest is just plug it into your calculator. You're going to get volume to equal, let's see, 6 squared is 36. 36 times 36 is 1,296, and we're going to leave it in terms of pi.
Yep, and we don't have to label that yet, any kind of unit like centimeters cubed, not yet, because we're not done with our final answer. So we're just going to keep going here. And we need to figure out the volume of the tennis balls now to find out what space is left inside. So I'm going to find the volume of one of the tennis balls first. So a ball is in the shape of a sphere, and the formula for a sphere is volume equals 4/3 pi r cubed. When we know all the information we need, we're going to plug in, well, 4/3 would stay 4/3, pi would stay pi, the radius of a tennis ball is 6, so we have 6 cubed. Plug and chug all that on your calculator, you get volume equals 288 pi. Now that's one tennis ball. We have 3 tennis balls. So I'm going to take this answer here, times it by 3 because there's 3 tennis balls, and that will give me 864 pi. This is the amount of space inside the canister taken up by the tennis balls. The question we were asked was how much space is left inside the canister not taken up by the tennis balls. Well, if the cylinder is 1296 pi, and the amount of space inside taken up is 864,
How are you going to figure
what
it
do we got
out?
to do? Subtract, right? We're going to subtract the 1296.
So if the whole thing, the whole cylinder, is 1296 pi, and each one of the balls are 288, you have to times it by 3, subtract all of it, and you should end up with 432 pi for the space between the tennis ball and the canister.
And that will label centimeters cubed because that's our final answer. So, nice job.